Hi everyone, Miss Colasso here. So in this video, I'm going to walk you through answering the first question in all of its parts for 4.3.5 practice. So as you begin this practice, you're going to see this graph, and that is showing the distribution of weights of individual dogs in a population of dogs. So this is giving us a nice bell curve where we see most of the dogs fall somewhere in that middle average weight, less in the lighter weight and less in the heavier. We really have that bulk in the average. So what I want you to really think about here is that this curve is going to indicate how fit the dogs are in that population. So this is saying that dogs who are an average weight tend to be the most fit, most likely to survive. So the first part of this question is saying draw a possible curve for the population if the population has a stabilizing selection. So now I'm going to show you the different types of natural selection in our class website. So here's our class website. You're going to scroll to lectures and notes all the way down to evolution. And then you're going to scroll a little past Hardy-Weinberg. And now we're in natural selection. So there's one video to kind of walk you through a very simplified demonstration of natural selection. And then I list the 3 types of natural selection that you need to know for this practice. So the first one is that stabilizing selection that we were just talking about. So this means that individuals with the average form, right, so around that 30 pounds, are going to have the highest fitness. So remember, fitness is the ability to survive. It doesn't necessarily mean like strength, strong, but it's their ability to reproduce. So this is saying that the blue curve is going to indicate the population over many generations. So I'm going to show you how to recreate this curve in your practice. So the practice does give you blank curves or blank graphs that you could make a curve on, but I think the best bet is to copy the first one so that you could base it off of that initial population. So I'll show you what that looks like. So you're going to copy it, Control C, go to Insert, Drawing, New. It might take a second to load, that's okay. And then once it loads, you could paste your graph. Okay, so I'm going to Control V my graph in this drawing. Let's see. There we go. I'm going to make it a little bigger. Okay, so this is what you're going to do. So you're going to paste that initial graph here. Now you want to add your curve. So you're going to go over to this line, use a drop down, and select curve. Now this could be tricky to make, but I'm going to walk you through it. So you're going to click at each point of the curve. So you're going to click once at the 10, then you're just going to drag it up to the 30. Now it's going to look like a straight line. That's okay. It's going to curve once we click again. So you're going to click again at 30, and then you get to bring it down to 50 and double click to finish. So see how we just created a nice curve where the most is in that 30 range. So now you could change the color. You could choose any color you'd like. I choose blue because I feel like it stands out most against the red. And then you could change the size of the line. So I choose 4 points just so you could really see it. Okay. And now there you have it. So you could save and close. And that is how you're going to complete part A of the first question. So you could write to your teacher, the blue line is going to indicate the stabilizing selection. Okay. So now we're going to move on to the second part. So there we go. We have another graph again. So draw a possible curve for the population several generations later if the population has directional selection. So now we're going to go back to our website, and directional selection is this one. So we're going to see a shift in the population to one extreme form of the trait. So in this case, this population is going to shift towards heavier dogs, dogs that weigh more. So we're going to see most dogs being most fit around the 40 to 50 pound range, which is very different from the initial population. So remember, this is over generations. We're going to see this trend. So now we're going to recreate this graph, and I'll show you how to do that as well. So we're going to insert drawing, and we should still have that initial chart copied. Just wait for it to load. Sometimes it takes a minute. Okay, so now it loaded finally. We're going to paste that graph here. Okay, make it a little bit bigger so we can edit it again. And now this one we're going to do the directional. So you're going to try to make it more directional towards the heavier dogs. So same thing, we're going to use our drop down curve. So now you're going to click at the 30, bring it up to about between the 40 and the 50, click again, let it curve, and then double click at the end of 50. So now you have your curve. And again, you're going to change the color and the size of your curve. And that is going to show a directional selection. Okay, so you could hit save and close. I don't know why that did that. Okay, so now this is going to be your directional. I don't know why I brought it all the way over here, but that's your directional. Okay, so now we see our directional, and the last one we're going to do is our disruptive selection. So that is going to look like this. So if we go back to our website, we could see disruptive selection. So that's where individuals with either extreme variation of a trait are going to have a greater fitness. So those dogs who weigh a little bit less are going to survive more. Those who weigh pretty heavy, so around 50 pounds, are going to survive more. But those who fall somewhere in the average weight are not going to survive as much. They're not going to be as fit and able to reproduce. So that's why we're going to see this M-looking curve. So for one last time, I'm going to show you how to make this graph. So again, there are these blank graphs, but I really would continue building off of the red just because it makes most sense. So I'm just going to try to add another drawing. Oops. Okay. I'm going to insert drawing, new. Okay, and then we're going to paste that same graph that we've been working with, the foundation graph, make it a little bit bigger. So going through the same process. Okay, now we're going to go back to our curve. So now we're going to do many points here. So we're going to start 1 all the way at the 0, bring it up to about the 10, click again, drag it over to about 30, right? Because we want that to be our lowest point. Then bring it back up to about 50, click again, and then we're going to double click at the end. And there we have our nice little M curve to show our disruptive selection. So we're going to color it blue again, 4-point font, or 4-point line, sorry, save and close. All right. And there it is. So now you have it and you could show each type of selection. Now the last part of this question is asking, how do these selective pressures affect the genetic variation in the population? So it's going to look different for each one, right? So if we go back to our website, we're going to see that it really is changing how heavy the dogs are and how that trait is passed down. So in this directional selection, we're seeing that dogs who weigh more are selected and able to reproduce. So that means that that trait for a heavier weight is going to be passed on more. Same thing here with disruptive, where, dogs with lighter or dogs who are lighter and weigh less are going to be able to survive and pass down that trait, as well as dogs who weigh more. So it's all based on the peaks of these blue parts of the graph, so you could discuss that for each type of selection. So that is how the genetic variation occurs. All right? So I hope this was helpful. If you have any other questions, please let me know. Thanks, guys.